Welcome, this is the function and behavior lecture PowerPoint. Here the learning target is for you to understand the end behavior of a function. The success criteria for this lesson for just the end behavior is I can find the end behavior of a function. But before we get to end behavior, I want to cover some questions on the domain and range. That's why these three first success criteria are here. You're going to be writing the domain and range in inequality and in interval notation. We'll start off with looking at an expression of the domain and range of a polynomial. Here we will see that the domain of a function is the set of all possible input values. So that is when you look left to right. If you look here, this is the domain. You're looking from left to right. You are going to see that from left to right, it's an arrow symbol. And the reason why it's an arrow symbol is because in the image, it's an arrow. So arrow and arrow. That means it goes on forever. Here, it goes all the way to negative infinity. And to the right, it goes all the way to positive infinity. That's why you can say that x is greater than negative infinity and x is less than infinity. Notice these are all opens at those endpoints. So the inequality will look like that, and if you put it in interval notation, you use the open parentheses because it is open on both ends. If we look at the domain, the range of a function is the set of all possible outputs or y values. So here you're going to look from the bottom to the top. If you look at this picture, to look from the bottom to the top is the range. The bottom here stops right here. That value, if you take a look, is going to be -6. So it stops here at -6. And it is closed here because it touches it. And goes all the way, and the arrow indicates that it goes on forever, and it goes to infinity. So the range would be from -6, then we close it, making sure we touch the -6, and the y is less than infinity because y is less than infinity, and it is open on infinity. If you put this on the interval, it should look like this. The closed bracket on the -6 comma, then infinity open parentheses. This is going to be your core concept on how do you find the domain and range. You have to be able to draw the image from left to right for the domain and draw the image up and down for range. Number 4, let's find the domain. The domain is when we look at it from left to right. From left to right, we saw that the arrow goes on forever. Arrow here goes all the way to negative infinity, and here it's the arrow and it goes all the way to positive infinity. So x is less than infinity but greater than negative infinity, and it is open on both sides. For the range, we see here that the range is when we look at it up and down. When we look at it up and down, here's the range in interval and inequality. Here's the domain in inequality and interval. Let's look at the range. This is how it looks like. The maximum value, or the from the bottom, it starts at infinity. It goes all the way to, this is the arrow, goes all the way to negative infinity, and it goes all the way, and from the top it is 4. So when you write it, it should be negative infinity. You make sure you open it, y, then you close it because you touch the 4. This does touch the 4. That's how it looks like in this inequality. When you write as an interval, you open the parentheses at negative infinity and you close it with a closed bracket at the 4 because it touches the value of 4. 5. For 5, we first of all look at the domain, and again, the arrow points in the left all the way to the right. And we know the arrow to the left goes all the way to negative infinity, and the arrow to the right indicates it goes to positive infinity. So x is less than infinity, and x is greater than negative infinity, and it is open on both sides. The inequality should look like that. It is open, negative infinity, you open it, less than x, and x is less than positive infinity. The interval, you open it at negative infinity, you also open it with a parentheses at positive infinity. Let's look at the range, which is the y value. To find the y value, we look up and down, and when we look up, we saw that it goes up in the arrow, and when we look down, we saw there is an arrow going down. So there was an arrow going up all the way to positive infinity, and there was an arrow going down here all the way to negative infinity. So the range would be y is greater than negative infinity, you open it, and y is less than positive infinity. It is open on both sides. That's how the range would look like in inequality. On the interval, it looks like the domain. It's an open parentheses, negative infinity, and a positive infinity, and you open it parentheses. Let's do number 6 now. Here, we would see it looks a little bit different, but the procedure is the same. The domain is when we look at it from left to right. When we look at it from the left, it seems like it stopped, and it stopped right here. This value here looks like it is the value 1. So it is the value 1 here. It's closed at 1. Okay, it's closed there at 1. Then it goes all the way to the right, and it keeps going. So it keeps going all the way. The arrow goes all the way to positive infinity. So the domain would be the x that is less than x is greater than or equal to 1. And you see how I closed it with the bar on the bottom at 1. And x is less than infinity, and it is open to infinity. So that's how the inequality looks like. Here you say x is greater than or equal to 1. X is less than infinity. If we look at the range, let's look at the interval for the domain. So it is a closed bracket at the 1, and it is an open parentheses at the infinity. Let's look at the range. The range is when we look up and down. We saw here it stops right here for the range, and that is a value of -4, and it's closed here at -4. Goes all the way up to arrow, goes all the way up to positive infinity. So the range, -4 is less than or equal to y, and y is less than infinity, positive infinity. So the range should look like that. Notice it is closed at -4, and it is open at infinity. So if it's closed at -4, it's a hard bracket or a closed bracket at -4, and it is an open parentheses at infinity. That is all your domain and range. That should give you a better understanding of domain and range. The next part of the video covers the expiration of end behavior. This is the end behavior of a polynomial. The end behavior describes the endpoint of a line. Here, you have a line. First of all, you're going to see this. That symbol is as x, arrow, negative infinity. What that means is as x goes towards negative infinity. That is looking at the left arm of the graph. If you take a look, this is what I mean by the left arm. Okay. This is when x, right here, this is when x goes to infinity, negative infinity. It goes to the left of the line. So as it goes left to the line, there is something happens. So y can happen in two ways. Y can happen in two ways. So the first thing that can happen is that it can go up. So y can go to positive infinity. And we don't ever see right positive, so we can say it goes towards infinity, which is up. Right? Here, let me color code this a little bit better. So as x approaches negative infinity, which means going left, two things can happen. It can either swing up, that means the y, okay, is gonna be that is the y is gonna go to infinity. That means it's gonna go up, or it can go down. The arm here can swing downwards, and if it's down, we can say y goes to negative infinity. This is when it goes down. Likewise, you can take a look on the right arm. So this is the right arm of the graph. And this is when x is approaching 1, 2, 3, 4. It goes all the way to positive infinity. As it goes to positive infinity, two things can happen. It can swing up. So it can swing up. This means y is going to go towards positive infinity. That means up. Or it can swing down. And swinging down is when y approaches negative infinity. That's the arrow. And this means down. Okay? So let me just make sure you guys got that these are arrows. Right? So these are your possibilities. The y can either go positive, which means it goes up, or y can go negative, which means down. Right? So there's two ways to look at this. The x is going toward the left arm, where x goes to negative infinity, or x is going to go to positive infinity, which is the right arm. Okay? There are four possible cases. The first case, we are going to look at the bottom left-hand side. So you're going to look at this bottom left-hand side here, okay? So we're going to see here, as x goes to left, that's what that means. What happens? We saw that it's going to go what? Up. So the y is going to go towards positive infinity. Y goes up. Then we would say that as x goes to positive infinity, that means as x goes to the right, what happens to the y? The y goes to positive infinity. That means y is going to go up. Up and up. Y goes to infinity. Y goes to infinity. Let's look at this case. I call this the sad face case. For the sad face case, we first of all look at as x goes to negative infinity, that means as x goes to the left, so we look at it goes to the left. What happens to the y? Well, the y goes to negative infinity. Why? Because it goes down. What about here? As x goes to positive infinity, that means you're going to the right. What happens to the y? Well, it is sad. It goes to negative infinity. That means it goes down. The left case here shows you that the x goes positive and the y goes positive and the y goes positive in both ends. That's what it means for it to be the endpoints. Here, you saw that it were both pointing down. So here, y approaches negative infinity. Let's look at these two cases where they're pointing in different directions. First of all, as x goes to negative infinity, that means as x goes to the left, what happens to the y? So look, it goes towards negative infinity. It goes down. What happens as x goes to positive infinity? That means as x goes to the right, what happens to the y? Well, here it goes positive infinity. It goes up. Notice that here the sign changes. Okay. For this case, as x goes to negative infinity, so as x goes to the left, this is when x goes to the left, what happens to the y? Well, the y becomes positive. It goes to positive infinity because it goes up. What happens as x goes to positive infinity? That means what happens as x goes to the right? Well, the y goes to negative infinity because it goes down. These are all your 4 cases that you're going to get when it comes to end behavior. There's no other way. Your end behavior with an arrow will show that it's going to go either to positive infinity or negative infinity, depending on how it turns. The several next problem are just problems for DeltaMath. Here we look at this graph and we look at this end behavior. So we would read the first one. As x goes to the right, y goes up. What that means, okay, as x goes to the right, y goes up. So this is up here and this is up here, right? Then as x goes to the left, right here, what happens to it? Y also goes up. Okay, up to positive infinity, up to positive infinity. So which one has positive infinity? Oh, this one is up. This one's down. So the answer would be this one. As x goes to the right, y goes up. As x, that's how you read this. As x goes to the right, which is infinity, y goes up, which goes to infinity. As x goes to the left, negative infinity, y goes up, which is positive infinity. Next case. Here, as x goes to the right, y goes down. So it goes to negative infinity. Goes down. So it should look something like this one, because this one goes down, or this one, it goes down, because that's where negative infinity is. Okay. Then as x goes to the left, which is this side, what happens to the y? Well, it also goes down. It goes down to negative infinity, goes down to negative infinity. So it goes down to, this goes down, and this is positive, so this goes up for the y. So it's this one. They're both going down. Let's look at this one. As x goes to the right, so this means it goes to the right. What happens to the y? Well, the y goes to positive infinity. It goes up. So y goes up. So it should look something like this one. Goes up. This one goes up. What happens as x goes left? The y goes to negative infinity. It goes down. So it's this one. This goes down, and this goes up. So this one, as x goes to the right, it goes up, and as x goes to the left, as x goes to the right, y goes up. As x goes to the left, which is x goes to negative infinity, y goes down. So it should be this one, the first one. Lastly, this case. As x goes to the right, right here, that goes to the right, we saw that y, the number, goes to negative infinity. It goes down. Then you have this. As x goes to the left, y goes up to positive infinity. It goes up. So let's take a look. When y goes down, it's negative. So this means it goes down. So it goes down here. So it's one of these two. And the second part is x goes to negative infinity, which means to the left. And this case means y goes down and y goes up. Here it went what? One goes down and this one goes up. So it went down, then up. So it's this one. Good. So there you go. All right. Those are all the 4 different cases for end behavior that you're ever going to need.